Well, hello, everybody. My name is Peter West, Professor P, and with me we have Travis from Peplink.
Peter, I love the blurb on the slide, live from somewhere on I-75.
I I thought that would be funny. It's just just kind of I'm actually sitting in a Arby's parking lot somewhere northbound on I-75 in Georgia. So I'm presenting from my Speed Fusion backpack. Uh, I've got my two 5Gs. I've got my cell phone tethered, and then I've got my car that comes with like that built-in Wi-Fi. And so so I've kind of got my car Wi-Fi, my cell phone, and then the built-in BR2 Wi-Fi or bonding, which I'll demonstrate here in a little bit. But today we're going to talk about what I've been doing for the last 15 years, which is transportation connectivity, mobility, healthcare, broadcast, RVers, uh, you know, what do you call me? Nomad, out in the field trying to just make sure you can work from anywhere. And so this one touches close to home for me because this is actually what West Networks does on a daily basis is solve connectivity problems for a number of verticals, but really challenging mobility space. And so I'm really excited to talk about that today. And yeah, let's get started.
Yeah, great.
So the first we're going to talk about is some of the challenges that people face on the road, and kind of how Peplink maybe addresses some of these things as well. One of the first things is location challenges, power and environmental. I can't tell you from the thousands of installs that I've done is that the ability to work, um, be able to provide power to units changes every single install almost. It's like, do they have a generator with AC? Are they running 12 volt? Are we tapping into like what I'm doing? I'm just plugged into a US, the cigarette lighter. How are we able to provide power? And one of the nice things about Peplink is that we have all sorts of power inputs, USB-C, regular, PoE, DC, AC. Most routers have more than one power input. And so you're able to really adapt easily to power concerns. And now Peplink just recently released that new, what I'm sure you know the part number, but the ACW dual USB-C to DC power input.
Yeah,
Um,
the splitter,
and
the
so now you
not
plug
splitter, the combiner.
two batteries in and actually hot swap batteries for continuous use.
Yeah,
And so phenomenal capability there for power distribution and making sure that you could power these devices while on the road. And then the other thing too is with environmental is ruggedized, is making sure they don't melt or overheat. And so most ruggedized Peplink routers, not the Soho devices, but our ruggedized devices are negative 40 to 140 Fahrenheit, meaning they support, I mean, almost all environmental situations. Obviously, I know there are some that exceed that, but almost all environmental situations. And I one time did an install and a mobile health unit where they had another product and it melted. Uh, like
oh
it
my
actually
God.
melted. It got overheated. It was a plastic enclosure. They had it shoved between a printer and a book, and it just I like, oh, my internet's not working. Can you come install one of your devices? I went down there as well. Just so you know, like that's not let's not shove it between a book and a printer. Let's put it on a shelf where it has a little bit of ventilation. But yeah, it was crazy. Couldn't even pull out the RJ45 because it had all melted together. Um
Into a
and
puddle.
so it was pretty fun for us because we come in with the rugged, but really any router would have suffered in that environment with being shoved with no ventilation.
Yeah,
Um,
you mentioned like 15 years working with Peplink, and that's something that really stands out for me is like all the customer calls that I've gotten on where they really push, right? You know that they've had that melted router experience, and they're like, "Are you sure this is gonna hold up?" Well, we're in Arizona, or we're in Dubai, or we're in pick a crazy hot place you can think of, and yeah, we don't have those failure rates, we don't have those problems. It's good.
and then the next challenge that we typically face is bandwidth requirements. and this used to be less of an issue. I mean, I've been doing this for a long time. 3G connectivity on wind farms and stuff. This used to be less of an issue, like for like RVers and passengers and things like that, where they, it's like, can I check my email or maybe do a basic internet traffic? But with Netflix and YouTube and Hulu and Teams, like if I'm working with you right now over Zoom and Teams and things like that, bandwidth has become a standard demand. People want more and more capacity as they go mobile. If I'm going to be mobile, I need to be connected. I need to have bandwidth. And so what we find is that even though one internet connection can provide good throughput, especially in a nice metropolitan area, they're not stable at scale, and
Mhm.
they I don't want to like I love so many carriers that there there's no stability at scale, and then they're diverse. Sometimes they can be great, sometimes they cannot be great. And so a lot of times what I try to say is no one connection is perfect because they
Yeah.
don't work everywhere. And so what we try to do is, can we get more connections? And that's where Peplink really starts to show its girth, is the ability to use multiple internet connections at the same time. And so with bandwidth bonding, we provide faster upload and download speeds. We have multiple cellular routers or even Starlink now, and then hot failover for constant uptime. And so the idea is, by using bandwidth bonding and hot failover, we can really achieve increased stability and reliability while working on the field or working out in the, roaming around. And so we like to be able to achieve those goals. And then another challenge that people have is a high level security expect to ensure privacy. And security is something that I get people ask me about often, and they think of Peplink as a WAN appliance, not a security appliance. And I have a whole webinar on firewalls, but it's neat to know that Peplink, not only do we have bandwidth bonding and we're ruggedized and we can have multiple SIM cards and Starlink and other internet connections, we also have a really nice firewall. I'm not going to say it's the best firewall, but a really nice firewall. We have content filtering, application blocking, layer 7 capabilities, DPI aware, inbound, outbound, and internal firewall policies with regional and SaaS capabilities. And if you don't know what those terms are, watch my firewall webinar. But my point though is that, you know, it, security is becoming more and more of a requirement, even for consumers, even for just making sure that your browsing habits and you're being protected while you're traversing around the country or the world. And you want to make sure that you have a router that has a good firewall. And so Peplink, with our integrated firewall, and I'll demonstrate some of those features today, allows for some peace of mind when it comes to security. And then when we talk about, we expand from the RV and the nomad, the individual running around trying to do a Zoom meeting, and we go to fleets and lots of devices. We want to be able to scale this. I want to be able to scale, hundreds or thousands of devices. And so when we take this amazing hardware and software platform and we combine it with in control management, now we have zero touch deployment. We have the ability to configure policies, push those out to tens of thousands of routers in seconds. And it's incredibly powerful tool to be able to have Wi-Fi and firewall and access control lists and zero touch configuration of your SpeedFusion bonding capabilities, all from in control cloud management. And so,
Yeah, I
and
think
then you add that it has GPS built right in. Oh, go ahead, Travis.
Yeah, I think that scaling is a big deal, like you said, not just multiple locations, but geographies, right? You've got people in different locations. That's one comment I hear all the time from customers in these mobile deployments is, hey, like you guys understand there's not going to be an IT person at this vehicle, right? Like I need to be able to run this thing from anywhere. And yeah, that's exactly what you're talking
I,
about. And
I was on a call last week with a healthcare facility, and the IT director, and I get this all the time, so nothing on this IT director, but he kind of started getting nervous, like how am I supposed to be in 7 different counties while you're traveling around providing desktop support? Like I like I don't want to, like that seems like a resource load that I'm kind of nervous to take on. And I started showing him in control and how we manage the routers and how we can use InTouch to RDP or VNC into desktops, and how we can use InTouch to remote control a printer. And so it's like from in control, from this one pane of glass, I can manage my desktops on the mobile health unit. I can manage my printers, my cameras, my NVR. I can make sure that my IoT appliances, I don't have to deploy a technician to troubleshoot something simple. Um, and so it by having in control and zero touch management and in touch, it really brings that power to the technician, so he doesn't have to worry about, which county are you in today and how many hours is it going to take me to drive out to provide a service solution. So
Yep.
really powerful kind of application suite.
Yeah, I think you
And
and
then
I take it for granted because it's just built in, it's automatic, and
it,
it's been there forever. And so new customers, they just don't have that comfort level, and they have not lived that way before. And then it's pretty easy to get used to, but it's not obvious at first to new customers.
and it kind of blows their minds too. Like, like, oh, let me just log into this. Like, I was trying to do some service for a customer on a kind of unique scenario. And so I used Docker, spun up an Ubuntu, VNC'd into an Ubuntu, and I ran all the commands, and the customer's like just floored with the capabilities that we were able to do in a matter of seconds and fix that problem that the customer is having.
Yeah.
So then we talk about the nature of mobility creates a complex dependability on providers due to the in-motion and multi-location nature of transit. I had to read that because I wanted to make sure I clarified that properly. But the as good as everybody wants to be, they can't provide 100% coverage. I mean, I am loving T-Mobile standalone right now. It is amazing, but everybody has their challenges. Everybody, I mean, it's impossible for them to provide complete 100% coverage. And while you're moving, while you're in motion, you have interference from trucks driving by, you have bridges and trees. If you're worried about Starlink, you have interference caused by other signals as you're traversing the country. And so we want to make sure that we can combat that as simplistic as, oh my gosh, as simplistic as possible. I don't want to, I part of that same conversation I had last week was, well, can we have a dashboard to train people how to switch? I go, you don't need to with Peplink. I don't need to have a dashboard. I don't want the users even touching the router. It's gonna,
Mhm.
because we have multi-WAN capabilities, because we can have Verizon and T-Mobile and AT&T and Starlink and OneWeb or anything else that we want to plug into it. Wi-Fi WAN. I'm Wi-Fiing my car's hotspot right now, and so I'm Wi-Fi WAN and Ethernet WAN and things like that. Literally, the idea is as these mobile units are traveling around, the end user is not thinking about how that connection is. It's just working and providing them connection. And I cannot stress that enough. It's one of the biggest things that people notice about Peplink when they're switching from a different hardware vendor. They're going, wait a second, I don't have to reboot when the tunnel goes down. Nope, it'll self heal. It's going to recover itself. I don't need to worry about rebooting when it doesn't work. If you have to reboot, something else is wrong. And so that's a big thing that we try to play on. It's don't reboot. If it's not working, let's look into why it's not working, because there's something else wrong. And it makes it creates a whole different scenario, or a whole different look at the environment when a technician's going, wait a second, so the answer isn't reboot. it's what's not working right now, what happened. And so anyways, that's a whole different offshoot of conversation. And then as we travel around, then once again having a good signal. And so high gain antennas and the modem chipset matters probably as much as I would love to say our bonding and our capabilities, but actually matter the most. You need to have a good antenna and you have to have a good modem.
Yep.
It's a requirement. And that's I was on another sales meeting, and I thought it was really cool. One of the ISPs was we were talking, and he goes, one of the coolest things like about Peplink is that they don't have 4-year-old chipsets on their new modems. They're always looking at the latest chipsets, the latest modems, to make sure that we're staying on top of the game, and making sure the
Yeah,
performance
basically.
is the best.
Yeah, there's basically, there's already a second generation of 5G chipsets on the market. We've been shipping those with our products the whole year, but most vendors out there don't even have a product certified on the second generation or even the first generation. If you look at the big vendors, they don't even have 5G products, or they're just coming out with them. And so,
Yeah, they're still running Cat 4s.
yeah, yeah. It's just like you see these LTE products from these big names getting registered on the carrier sites every day. And it's just like, why did they do that? What was that
And
for?
honestly, that can also be a frustration too. But you got to think of it like cell phones. Like,
Mhm.
you get an iPhone 12, and then the iPhone 13, and then the iPhone 14, and iPhone 15. It's not just the hardware. It's also the wireless chip, the modem, the processor, the module. They're running the latest modules. So you
Yep.
compare a iPhone 15 Pro Max with millimeter wave to a 7-year-old BR1 Mini Cat 3, it's not going to be as fast. It's going to be different. And so those
Yep.
modems, we got to keep up with those modems. But also, we need to make sure we have antennas that can send and receive the signal that we're trying to achieve. And so by having the latest modems and high gain antennas, we increase that opportunity for really reliable connectivity. And I always talk about like an opportunity cost. We're trying to maximize the opportunity of connections. And so by having good antennas, good modems, we're able to maximize that connection opportunity. And then we take the speed fusion and the multi-WAN and the diversity and the other features to be able to maximize the utilization of those modems. And so it's kind of like you get both. You got to have both.
Yep.
Um,
Yeah, and the antennas matter a lot on the 5G world. People, I see this all the time. Customers, they try to take 4G antennas and plug the 5G unit in. They say, okay, well, I've only got two antennas. Which ones should I plug them into? No, start over. Get four, do
Rip
it
it out and
right.
put a new one in.
Yep. Do it the way 5G is supposed to work, right? It will work way better, and it will give you much better range and speed.
Yeah, 100%. And then cellular congestion creates bandwidth issues in high density environments. And so cellular congestion is something, especially if you're a broadcast or first responder, this we're really speaking to you in this right now, is that you're at the Super Bowl, you're at a football game, and you got 100,000 people around. You have congestion issues. This is not about receiving a signal. It's about there's 800, that's an advantage. There's 100,000 people on the towers sucking up a gigabit pipe or a 10 gigabit pipe, and there's just not enough internet to go around. Um, and so my old way to talk about this, which we still agree with, is quantity. So if and just to break the math down a little bit, if there's 100 people, if there's 10 people on the network and 100 megabits of internet, and they're all using at the same time, there's 10 megs per person. If I'm two of those people, I have two SIM cards. Now I have 20 megs of throughput instead of 10 megs. Well, you take that, if there's a gig pipe and 1,000 people, you only have 1 meg a person. That's not, I mean, a gig seems like a lot, but when you have 1,000 people on the tower, that's only 1 meg per person. And so now, give it, they're all not using it at the same time. There's algorithms and ways to optimize this. But the point though is that it's important to understand that congestion is a battle that especially the broadcasters and the first responders have to deal with. And so there's two ways that we handle that. The first is just diversity. Have multiple SIM cards, and then maybe even have multiple versions of each carrier. So I have two AT&T, two Verizon, two T-Mobile. Um, then we have dynamic weighted bonding. Dynamic weighted bonding is monitoring the connection from your mobile router to your hub, to your Fusion hub or your balance router or your Speed Fusion Connect, and it's monitoring the packet loss and latency and jitter to detect congestion and maximize the utilization of each circuit. So if T-Mobile can give me 150 megs down and AT&T is giving me 50, I'm no longer throttling the T-Mobile to the 50 megs of the AT&T. the T-Mobile can get 150, the AT&T can get 50, the Verizon can get 100, and I can maximize each one of those circuits together. And so dynamic weighted bonding combined with multiple SIM cards really increases the ability to combat congestion specifically.
Yeah, and I think dynamic weighted bonding just can't be undersold here because, we're
Mm-hmm.
starting to see a few people in the market introduce bonding finally, right? Peplink, we've been doing it for 15 years, right? This isn't new to us, but
Bonding.
we're starting to see a few players out there that are talking about bonding, but Peplink is just hands down the fastest, highest performance, most efficient way to bond connections, period. Nobody can come even close to our 15 years of experience doing this. And that shows up in every side of the market, right? Peter, you've won projects against the biggest SD-WAN players in the world because Peplink's technology was superior. But that same algorithm is also in these low-end $599, $999 mobile products. So you can have that capability anywhere.
The not that this discussion is about that, but one of the biggest problems with these other solutions is most of them are just taking advantage of multipath TCP, and it's not actually bonding. So they're throwing up on it like an AWS multipath TCP host, and then basically creating that session for you. And so it's important to understand that packet-based bonding and what we can do by monitoring the health of each circuit versus just a multipath TCP, very different utilization of the technologies. Where we have, like I said, like Travis mentioned, we have 15 years of experience optimizing and monitoring and managing and maximizing the capacity of these circuits, not just throwing some open standard out there and hoping that it works. I'm
And
not
really
that
to just boil it all down, what that all means, it behaves like what Peter was talking about at the beginning, where you don't have to think about which connection should I use now, what should I do here, what should I do there. That people have that experience because our algorithms work so well and are so dynamic and automatic and able to adjust real time like that.
Amen. And then one of the last things that we just wanted to plug here is more of just a little sales plug, but a lot of times people come to like, how do I know which is the carrier is the best? And we don't, right? They differ by square mile almost. And so, or even block sometimes. But so
Yeah.
Peplink also has our eSIM data plans. And so you can load multiple profiles. So if you can load Verizon, T-Mobile, and AT&T onto your modem via eSIM profiles, or you can use SFC data, and you can actually have a single data plan that lets you test all the carriers so you know what to provide and what to connect. And so using either SFC 5G to be able to switch between your carriers, or the ability to have eSIMs and plug in directly AT&T, Verizon, T-Mobile, and have all three of those together, creates a massive increased opportunity for the best possible connection. And so, eSIMs and our SFC 5G, combined with dynamic weighted bonding, combined with the high gain antennas and the multi WAN and everything we just mentioned, puts together a package that creates incredible resiliency and reliability on the road.
Yeah, I think those eSIMs are something a lot of people don't really appreciate, but like you said, kind of everybody's got their carrier that they like, and maybe they're in this area most often, and I know T-Mobile or Verizon or AT&T works best here or there. So everybody's got that kind of first carrier figured out. That's not too hard to get a SIM card and get that activated, and maybe you're going to add it onto your existing plan that you've got all your other lines, but yeah, when you go into that area where that carrier just happens to not be so great, and maybe you're only there 5% of your time, but now you're down again and you're back to the old way of doing things. And so those eSIM plans are great for filling in those gaps so you don't have to go find a whole nother contract with a whole nother carrier and pay a whole nother monthly bill, right? You can just pay for the year and get that kind of failover, backup, roaming, whatever you want to call it, but make that experience easy. And again, take one more question out of the whole process of how do I do this now?
Amen. And so now we've kind of gone over the generic that covers all of these. So we wanted to introduce you to the basics of Peplink and mobility. And so now we talk about connectivity for your vertical or for your mission. And there are a lot of missions, by the way. We wanted to. I mean, I could talk for hours on this. So I kind of picked some of the five that I thought fit well for the majority of our customers, understanding there's a lot of verticals out there that are we're trying to solve problems for. Um, we basically have like essential connectivity, passenger connectivity, critical connectivity, healthcare, and broadcast. And so we're going to talk about, and the reason why I broke this up is because between those five groups, it kind of covers the plethora of Peplink hardware technologies. And I get asked all the time, why do you have so many routers? Why can't you just have a router? And it's because we have a lot of different customers with different needs, and not there's not one router that's fixed. So, I mean, like I said, I guess if everybody bought an EPX, then fine, great. But I don't think we're going to install EPXs in 18 machines. And so, we wanted to have, we need to have hardware that solves your mission, and everybody's mission is slightly different. And so we're going to categorize these into these five categories, and show you hardware and technology that complement those categories and why we have the different hardware that we have. And you'll see overlaps here, by the way. So the first is going to be essential connectivity. And the idea here is there are people out there that whether it's IoT, or just a dash cam or a monitor or a sensor, basically they're trying to use low bandwidth with normal reliability, and they're trying to create that connection so they can use in control and in touch, maybe fleet management with GPS, and create this reliable connection. And so we have the BR1 Mini 5G, and the BR1 Mini 5G is a low cost 5G adapter or router. And that's what's nice about this. You could plug this into an existing infrastructure, like a non-Peplink firewall, or you could plug this right into your vehicle and have it set up for basically nice 5G connectivity anywhere you go. Not really designed for your high bandwidth applications, but it's designed for your IoT and once again, normal reliability. And so that's why we've categorized this under essential connectivity. The next thing we have is passenger connectivity. And right here we have connectivity for RVers, but this would really be connectivity for RVers, buses, public transportation, anytime you want to have passengers with Wi-Fi. And the idea is you could have a Transit Duo Pro or a BR1 Pro 5G, and the other one that should have been here is a BR2 Pro 5G. But the idea here is high bandwidth with normal reliability. And so you'll see why we go into more high bandwidth or higher reliability. But the idea is they're going to use more bandwidth, higher bandwidth, but they're not, the mission isn't extreme reliability. If you don't get that high bandwidth for a few minutes, it's okay. You're usually streaming Netflix or YouTube, checking your email, running a Teams meeting, or running a Zoom meeting, and trying to travel around. And you want to keep the cost low, the bandwidth as high as possible, but it's not critical that the bandwidth is high. And so what's neat about the Transit Duo is you can synergize them, and basically, and I've got a whole video on this, and basically make a really budget-friendly quad 5G or 4G appliance. Or you can use the BR1 Pro 5G, which has Wi-Fi 6 to broadcast. It's going to cover your entire vehicle with good Wi-Fi 6 connectivity. It has the 5G chip there, and then you could also pair that with a Starlink to give you better roaming and capability in areas that maybe you don't have any 5G service. But the hardware cost is going to be lower. You're only going to have one SIM card plan for the BR1 Pro 5G, so your monthly cost is going to be lower as well. But you're going to be able to get the high bandwidth of 5G, but with that standard reliability. I understand that some spaces might be less.
Yeah, I think one way to think about that, on the single side, I heard it explained to me is like, okay, if you pick the 5G device, what's your maximum? You're maybe going to see like 300 megabits per second out in the real world on that thing. Sometimes maybe a little bit more, but you get into that congested or kind of crunch scenario, and let's take that. Maybe that tower's 90% loaded. Well, now I'm at like 20 or 30 megabits per second. That my downside is pretty good still. Or if I started out with a lower speed 4G device, maybe my peak's 40, 50 megs, get 90% crunched down, and I'm only at 2 or 4 megs now. So yeah, when you start out with that faster, more capable device, the worst case scenario is going to be better still, both on coverage and on the throughput overall. But
And on top of that, I mean, we talk about the that's where I talk classify like normal or standard reliability, right? Those
Yep.
variances and the throughput are okay. Versus
Yep.
when you talk about a high availability, which we're going to start to go to, we need to make sure we have those peaks stay more constant. So
Yep.
high reliability, we're actually talking about reliability of the circuit. And that's why, the Transit Duo, for example, is dual 4G. So the peaks are going to be lower, but it's going to have increased bandwidth because we can have two of them together. We're going to bond those together. So that's sort of a middle ground of higher reliability, but maybe the peaks aren't as high because it's not 5G, but we're still keeping the budget low for passenger connectivity. The other cool thing about passenger connectivity is Peplink technologies that really are are strong here are built-in captive portal. So not only do we have the ability to have um, good internet, we also have the ability to have a captive portal. So if you're a transportation like a bus company, you can have, hey, here's my bus company. And then when they log in, especially on the Transit Duo Pro, you then have application caching. So you could have your own internal website that says, here's our media, and you can have content there that you can stream with Docker or application caching built into the router. So you could have, videos.yourbuscompany.com and actually have videos that they can watch that are stored locally on the device and not even consuming data. So, everybody could watch one or two movies for a 2 hour bus ride or a 4 hour bus ride and not consume any data. And so there's some neat technologies built into the routers that allow for even better passenger experiences like Docker and application caching.
Yeah, I think those are all the details that get overlooked so easily. And then you start, then on our side, we see these kind of like Frankenstein solutions that end up because somebody picked this router because it was the cheapest and it connected and all that was great. But then they realized, oh shoot, I need this captive portal solution. So they plug this Wi-Fi access point into that router. They start kind of like hodgepodging all these things in to solve these details that they didn't really realize they were going to face on the front end. And with Peplink, we've got all these hardware models, so you can just get the right size, but then we've got all this software behind it that works with any of those models. So you've got that common experience no matter which one you picked.
Exactly. And so then we talk about critical connectivity, and it's weird. This is a very weird topic because I have two really high performing routers that then we talk about low bandwidth. When we talk about critical connectivity, we're talking about police cars and ambulances and fire trucks, but then they also have command vehicles. So they have the critical response vehicles. So we talk about a police car, an ambulance, a fire truck. They actually don't have a high bandwidth need. What they need is super reliable bandwidth. So they don't need it to be high. They need it to be incredibly reliable on those police cars. And so when I talk about the BR2, the reason why I recommend this instead of the Transit Duo or another router is because the band frequency. The BR2 Pro 5G is dual 5G. So it actually has a really high up end. Um, but if you talk about the high up end for high bandwidth, the higher the bandwidth requirement, the lower the stability or reliability of that bandwidth will be with less SIM cards. So the idea with the BR2 is low bandwidth, super high reliability, or high bandwidth, normal reliability. So you can kind of flip that around with the BR2. And and so with the BR2, the reason why I recommend this for first responders is the 5G chipset offers more frequency, more bands, higher bonding capacity, which means that for their low bandwidth needs, like Travis just said a second ago, the highs are going to be awesome, but the lows are still going to be exactly what they need to complete the mission. So you pull into 100,000 people and you've still got 5 or 6 or 10 or 15 megabits of throughput. That's all a police car needs to be able to stream their videos, to access their systems, their CAD and their reporting programs. And so that's where the BR2 Pro is an amazing opportunity for low bandwidth, super reliable. And that's the difference there. It's a weird one that you might not think about. And that's why I wanted to have this because the routers can fit multiple different platforms. Then we go into
Yeah,
command vehicles. Oh, go
I
ahead.
think
Sorry.
one way to think about it that just kind of hit me is like, like you said, it's not about the speed, right? That 500 megabits per second on 5G doesn't do the police car anything, right? But if you think about it like a fishing net, maybe like your modem is like how big your net is, right? These 5G modems have all of the frequencies, all of the bands, and so they're a really wide net, so they can catch any of the bandwidth coming off of that cellular network. Where if you've got a really small, older 4G device, you don't have that much bandwidth you can even catch to begin with. So you're competing with everybody else with a much smaller net versus these big nets that, and so again, it's not about that peak, it's keeping things good when there's not much to catch there.
Yep, I like that. And then for command vehicles, they need more bandwidth, but they still need that super reliability. And that's where the HD4 MBX comes in. Now we have 4 SIM cards, 4 5G modems. We can have 2 or 3 Starlinks, or you could have more 5G modems with USB expansion. So there's actually 2 USB ports there. So you have a total of 6 5G modems with the max adapter. And then, like I said, 3 Ethernet WAN, so you can have Starlink or even additional 5G modems. And so the HD4 MBX provides PoE LAN ports, increased hardware reliability, but also incredible scalability to achieve that, to accomplish that mission. So the HD4 MBX has more SIM cards, that 5G end platform. So we're going to, once again, get that super reliability that we need, not necessarily pushing high bandwidth that we're going to talk about in the next couple categories. So it's still, I would still a medium to low bandwidth requirement compared to some of these next couple categories, but super reliable bandwidth. And that's where that HD4 comes in on your command vehicles. So the BR2 for your police cars, ambulance, and fire trucks, the HD4 for your command vehicles gives you almost guaranteed low bandwidth, that you're going to low and medium bandwidth for your mission, but super reliable. And then you pair that with SpeedFusion VPN for AES 256, TLS 1.3, NIST compliant security. We're going to have that encryption and security you need for your traffic. So you don't have to have an additional VPN topology like some of these software-based VPNs. You're going to be able to hardware VPN this right into your environment to create a super secure, stable connection for your first responder critical connectivity vehicles. Healthcare. This is my baby right here. So I live in the healthcare world for the most part of my journey through SpeedFusion, and we've played around with products a lot. And healthcare we call high bandwidth, high reliability. This is one of the most challenging environments to provide connectivity, because when you're doing like DICOM imaging, for example, like PACS and X-ray images, if you lose a single packet, the entire image has to retransmit, because that could be a false positive or false negative that is not seen for an image, a radiology image. And so that it has to be incredibly reliable, but they also need a lot of bandwidth. So it's high bandwidth and high reliability. And that's a challenge to overcome. And we've done this with these high performance routers. Let me talk about the 2 categories that I take into for healthcare. The first one is telehealth services. Telehealth services are very similar to our critical response or our police services. We need to be able to have kind of a medium or normal bandwidth, super high reliability. And so we have the BR2 and the HD4. This is going to allow you to use WAN smoothing to be able to do Teams calls and voice calls for telehealth operations, access their EMR, their Epic, or their other platform they might use for healthcare services, and be able to work on the road. And you can pair that with Starlink to increase the diversity and capabilities as you roam around the country. But then we go into our high bandwidth needs for MRIs, CT, mammographies, dental imaging. This is a challenge that is seldom addressed by most by kind of like local IT, because they go, how do I solve this problem? And I don't know, like I'm gonna throw a router out there. And so I wanted to put this slide out here so that basically it was public knowledge of what we're trying to do with the SDX and the domes, or the EPX and built-in 5G. We can combine 8 to 16 internet connection, 5G internet connections together to create incredibly high bandwidth, high reliability connection back to the hospital. This means real-time imaging, real-time CT, real-time MRI, real-time mammography, real-time dental. We're transmitting images as if they're sitting in the hospital. And we're doing that by bonding up to 16 5G modems. You can do more, but it's not that it's not like the physical space on the roof with air conditionings and things like that. Um, and it's not necessary, I guess. But the idea is we combine up to 16 5G modems together to create an incredibly highly reliable, high bandwidth solution. And one of the things that I really like about this, especially in the healthcare world, because they're high bandwidth, means they're using lots of terabytes. Well, the carriers sometimes they go, oh man, terabytes means dedicated data plan. That's what they're going to try to sell you, dedicated data plan. Well, if I have, just say 10, if I have 10 SIM cards and I have 10 300 gigabyte broadband plans, now I'm only paying pennies per gigabyte on the data plan because I'm buying a broadband plan, but I have 10 of them. So I have 3 terabytes of capacity on this router. So that the ROI of buying one of these 10 cellular devices compared to paying for 3 terabytes of data is almost 1 month. I kid you not. The ROI of the data plan itself is incredibly valuable to these healthcare facilities. And if you think about most mobile healthcare, they're serving underprivileged areas. Almost all of my mobile healthcare, it's can I reach people that can't be served? And so they're running on a budget. How do I save money and provide this service? How do I make sure that I can see these people and provide them the same quality service that they would get if they were in a hospital? And that's why this is so close to home for me. It's my passion. It's they're serving people that can't be served. And so we got to keep the cost down. We got to make sure it's fast and reliable, and we got to make sure they can serve their community. Now, CT and MRI, it's a little bit different. That's about speed. They got to save lives in a matter of seconds. They get a couple minutes to decide what medication to deploy. And so once again, we increased reliability and throughput. And so we're able to combine those SIM cards to create a lot of gigabytes, a lot of terabytes for them to be able to provide that service and creating that like hospital environment. And that's the power of the SDX and the EPX when you talk about mobile healthcare. It's incredibly powerful and provides the bandwidth and reliability at the cost savings or the cost that they need it to be. And then to make all things awesome, pair that with Starlink. So 2 or 3 or 4 Starlinks, and now you have, I mean, basically complete countrywide connectivity without ever having to skip a beat. And so, yeah, it's an incredible combination of technology that has Peplink's years of experience, but adds into making the most robust mobile network you can possibly have.
What I love about this, Peter, and I can just hear it coming out of your voice, is like you're not building a mobile hotspot or a mobile connection here. You're building a hospital grade network. It just happens to be in a vehicle, right? You're not building this as like, oh, I can't have everything I want, so I'm just going to give them this pretty good thing, right? No, you're building a hospital grade network and it's in those vehicles so they can use it anywhere, like you said. And so it's not, this is a mobile conversation, but you've been able to take this template to all kinds of other brick and mortar facilities on top of that, because you're building it just like a network engineer would design a new facility, right? I've got this diversity on my connections and this diversity on my power options, and these are the things that make these networks reliable. And it's the same thing here.
It's a lot of fun too. To show these hospitals, it's like you can have a hospital on wheels with Peplink, and
Yep.
and then they apply it to their buildings. They go, wait a second, if that works out here, can I add that to my branches? They have a fiber cut, and they go, so I can have internet as fast as my fiber out in the field. And yes, you can. And so, not only can you apply this to mobility, but it can be your branches as well. But this is a mobility webinar. The next one is broadcast. Broadcasters have really leaned on 5G and Starlink to achieve real-time transmission capabilities at immense cost savings over traditional means or even just over more complicated means like dedicated microwave towers and things like that. And so the ability to have extremely high bandwidth with extremely high reliability comes into play with the same kind of topic we were had before, but with the EPX and the HD4 MBX, and then pairing that with Starlink and other internet connections like your venue internet and your venue Wi-Fi, pairing with taking all the internet that I can get, because usually a broadcaster goes out and they buy a gigabit line. They have internet where they go, but you got to remember when when an event is over, when the president speaks and then he's done, it's gone. It's done. It cannot fail. And that's where the extreme reliability here. If it takes an extra 3 minutes to transmit a mobile mammography image, most people won't notice 3 minutes. But if you're down for 3 minutes on a broadcast, you're down. You've lost that 3 minutes. It's gone. And so what we try to do is we say, okay, look, yeah, you might have venue internet, you might have venue Wi-Fi. Let's take the venue Ethernet, the venue Wi-Fi, the guest Wi-Fi. Let's take 4, 10, 15 5G modems. Let's take Starlink, combine them all together, and create the most extreme bandwidth and reliability that we can. Use every possible internet to make sure that if you're trying to transmit real-time mission, it is going to be achieved in real time for your mission. And that's why the HD4 MBX and the EPX platform have become almost an industry standard for extreme reliability for our broadcast customers. We've been deploying them all over the country and probably all over the world just for other partners for extreme reliability, real-time broadcast. And then Peplink has, we talked about WAN smoothing for our healthcare. Forward error correction has been built for the broadcasters. The ability to add parity and increase reliability while maximizing bandwidth. So once again, it uses less overhead than WAN smoothing, but adds parity to ensure delivery of those packets. So when you're transmitting, if there's packet loss on those circuits, it's going to be received as a full complete package. Really optimized for that UDP transmission for your video streams, and being able to combine integrated 10 to 12 5G or external way more allows you to really have the amount of bandwidth you need to accomplish the mission. Basically any bandwidth size we can accomplish by mixing these carriers together, whether it's 4G, 5G, Starlink, Ethernet, Wi-Fi, etc. We're able to combine all those together to create the most possible bandwidth to achieve and accomplish that mission without. And then with WAN smoothing, with forward error correction and speed fusion, there's zero packet loss. So you can lose an internet connection and you're not going to drop those packets. You're not going to drop the connection. And so it's going to, your real-time transmission, your video transmission will stay stable. And that's really what we're bringing to the table when we talk about extreme reliability for broadcast.
Yeah, I think the thing that comes up every time when we talk about broadcast is, well, what about live view? And I think to me, it's like, okay, live view is a kitchen gadget, right? It does like one thing. And it does that thing really well, right? It's going to mandolin the crap out of that video feed, right? But it's not going to do all the other things that you need to achieve your mission, right? It doesn't support the voice communications applications. It doesn't support a remote production engineer getting into this device and changing these settings, right? It only does
or accessing your PTZ cameras.
Yeah. It's great at that little thing that it does, but it doesn't support the mission. It doesn't support the completeness of the mission that these people are tasked with when they go into these areas. It just supports one piece of their mission, and that's what Peplink does so differently.
Well, what I find really funny, and only because you brought it up, I try to keep third parties out of it, and since you brought it up, it's surprising me how many customers will actually take their live view and plug it into the Peplink.
Yeah.
It's like they'll use it as an encoder, but then they use the Peplink for the transport.
Yep.
And because they only have to pay for one set of transport. Instead of paying for transport on the DeGiro or the live view or whatever it is, you pay for the transport on the Peplink. It solves the connectivity problem, and then they use the live view for encoding. And so you're only paying for one data set, one connection set. You're not paying for multiple connection sets.
Yep. Yeah, exactly. Yeah. The scale, right? You start,
Yeah,
okay, that's cool for this little small thing, but now we've got 10 cameras and now we've got a truck, and it doesn't hold up when you start throwing more scale at it, frankly.
yeah, exactly. Um, so I left, I got 7 minutes here for Q&A. Um, so I'll leave that open there for you. I didn't see, do we have the Q&A section? Because I didn't
I
see it.
kind I kind of answered one of them there, but
Okay.
not in
Oh
a
yeah,
not
okay.
directly, but
So yeah, so if you have any questions, feel free to ask. Otherwise, I'm going to do a quick just show. I mean, our webinars, we talk about technology, but I wanted to kind of showcase a little bit the like even right now, I just thought it was kind of fun. I'm running. So my backpack, I've got my backpack, and if you haven't seen me post all the time on LinkedIn, I have it. I'm sitting in my car right now, so I don't have my antennas on the roof. I'm not in my RV where I have my HD4 MBX and my Starlink and my antennas. I'm in my car, driving up to Ohio for a project tomorrow, and I wanted to make sure this call went well, and hopefully it did, Travis. So hopefully my audio and everything was good, and so
sure.
I wanted to make sure it was well. So I have my T-Mobile, I have my AT&T, but my car also has Wi-Fi. It's you pay like what, it's like $200 a year, and you get kind of like that Wi-Fi hotspot the kids throw their iPads on. And so I have my Wi-Fi on my car, and then I have my Pixel, which also has T-Mobile on it, and so I have that. And so I'm then bonding all those together with WAN smoothing. So if I go into my remote web admin, you can see there's my connection. So I'm using my Wi-Fi WAN there. I've got my cellular WANs. I've got my Wi-Fi that I'm connecting to. That's what my tablet is on right now. And I've got my little my Bluetooth keyboard, my Bluetooth mouse, my Bluetooth headset, and a tablet mounted to my window here. Um, and then if I go to my advanced Speed Fusion, there you go. So I've got my Speed Fusion set up, and I've enabled WAN smoothing. So there's my WAN smoothing right there. And so what I'm doing is I'm adding parity bits. I'm duplicating packets across those 4 internet connections so that I'm maximizing the delivery of these packets. So if any of those, 2 of those connections could fail, it basically, you wouldn't even notice on your end receiving this video call. And then
Yeah,
I
there's
have an
no
out,
failover time. It's instant,
yeah,
right?
it's instantaneous. I'm duplicating the packets. Then on my outbound policy, I have an outbound policy that's enforcing my connection over that Speed Fusion tunnel. So I wanted to make sure that everything that I'm doing on this tablet is going over Speed Fusion. It's connecting back to my SDX or my EPX. It's sitting in Gainesville, Florida, with my 3 gigabit fiber line, and so I'm sending it all over there and maximizing the reliability. So as I travel around today or this week up in Ohio and traveling up and down I-75, I'm taking, I'm getting the most reliability, and that's what I wanted to guarantee here is reliability. And so I've got the BR2 with my 2 hot Wi-Fi connections, giving me 4 connections total, and then I'm WAN smoothing those with parity to make sure my Teams calls are stable. And I am parked and safe, so I'm not driving right now. But the idea is that these meetings that I can have while I'm traveling stay stable. And I do this all the time. If you've ever hired my company to do an install, we typically drive, and so I'm in one of either my Speed Fusion vans or one of my cars, and I need to be able to have meetings, provide tech support, and make sure I have webinars like I am now. And so I use the same technology that we're talking about to accomplish my mission. And so I just wanted to share that with you, and I guess we will see if we have any questions that matter or that sorry that came out wrong, any questions that I can address. So synergy mode doesn't work with Starlink. Oh, you're typing an answer, sorry.
I am, but yeah,
Synergy,
go
yeah,
for it.
so we have synergy mode, which is the ability to combine Peplink routers. So say if I wanted to have more bandwidth permanently in my backpack, I could actually take the max BR1 mini 5G plug it into the WAN port on my BR2 and have 3 5G modems on my BR2. That's synergy mode. So synergy mode combines 2 Peplink routers together to make 1 super router. Starlink mode is a separate mode. So if I go into the network tab and I go to WAN, I have my synergy controller, my synergy mode, and then I have my Starlink mode. And actually, if you look at my Rebel, so this is my RV, and currently when I'm not driving, by the way, I suspend my Starlinks. That's one of the nice things about Starlink. So that's not failed. It's just but so I have synergy mode enabled, or not. I'm so sorry. I have Starlink mode enabled on that WAN, and you can see the little SpaceX logo there. And if I click details, you can actually see my UID. You can see my obstructions. There you go. So my time extruction, my time extracted, my fractional obstructed. So I can see details about this Starlink dish. I can even reboot that dish. So I can click reboot, hit yes, and it will reboot that Starlink modem that's on the roof of, and this will actually go to no connection here in a second. Now, wait a second, right now it's down because I've suspended the bill. I don't want to pay for it if I'm not using it. But then you can see that I've got my cellular WANs. So Starlink WAN is different than Synergy mode. Synergy mode combines routers. Starlink mode enables the Starlink this kind of modem capabilities built into the Peplink router.
They just both came out in the same firmware, so it sounds like they're like part of the same thing. But yeah, there is distinctions there.
Yes, Starlink info works on any 8.4.1 router. So if you have a BR1 Pro 5G, it would also provide it. You just have your one WAN instead of your dual WAN. So you're right there, no cable detected. So I clicked that reboot and it rebooted that Starlink dish.
Yeah, we get this question a lot, like, oh, which model do I need to have the Starlink capability? Any model. Does not matter. All Peplink hard models with an Ethernet WAN port support Starlink mode. It's just you need that firmware that has to be able to run 841.
Yep. Okay. Well, it's 1 o'clock. So thank you so much, everybody, for joining me on this mission. Transportation and mobility is, like I said, something that's really close to my heart because it's what I do for my job every day. And so I hope that this helps you understand it a little bit better. And if you have any questions, you can always reach out to Peter at westnetworks.com or Travis at peplink.com. And we'd be more than happy to answer any additional questions as well as provide you with partners and resources to help you solve your mission. So thank you so much for joining us today. And thank you, Travis, once again for hosting.
Peter, thank you as always. You bring tons of real world knowledge to the community, so it's always fun. All right, folks, take care.
Have a good one. Bye.
Bye.